Welcome to Complexity Made Simple. My name is Paul Allen, and the subject of today's newsletter, well, we are going to talk about machine learning and artificial intelligence and how that might help or hinder the Six Sigma process. Okay, so we're going to talk about, here it is, machine learning. Machine learning and how it works versus Six Sigma, or the Six Sigma journey. So the reason I'm recording this video, last week I was at a conference. I was at an international Six Sigma conference, and I was quite surprised how many of the speakers turned up and talked about machine learning or artificial intelligence. Obviously it's clearly a subject that lots of people are talking about, artificial intelligence. Will we have self-driving cars and all this type of thing? But they were talking about it from the point of view of process optimization. All right, so what I want to do is kind of place machine learning in a particular place in the Six Sigma journey, because you need to be careful. People love to buy technology and they always think technology is the answer to all of their problems. So let's start by reminding you of the three states your process could be in. Your process could be in a state of chaos. It could be in a state of control, or it could be in a state of excellence. Now here's the kind of advice. Here's the thing you've got to be really careful with. You see, chaos, control and excellence. The way I would describe this is that chaos is about controlling noise. Excellence is about controlling signal. And you have to be able to do both to get to this point. In fact, excellence stands on top of control. Now for me, this is where machine learning sits. It sits in the excellence phase. But actually, the excellence phase is very easy to do. You don't need fancy computers to do the excellence phase. What's really hard to do is to go from chaos to control. So let me just put this in a graphical form to explain what I'm talking about. Here's your process. Highly chaotic. There's your tolerances. Okay. Look at this thing. Here's the target. If you look at your process, and let's draw the process capability diagram that goes with this. You see, you don't have a problem with the signal. You don't have a problem putting the average on the target. What you have a problem with is noise. You have a problem with noise. You have a problem with control. So just to kind of reference a case study that was presented last week at the conference. They presented this case study, which for me was all about excellence, which was about putting chocolates in the plastic tray that then goes in the chocolate box. And they were teaching the robot, there was a robot loading these chocolates in. They were teaching the robot how to avoid mistakes. So chocolates that were put upside down, chocolates that maybe were broke or damaged but still placed in the tray, etc. So they were teaching the robot how to, and they were using machine learning to do this, how to get the robot to get it right, essentially. Okay. Now, they presented a case study and it was all fine and dandy and it worked brilliantly. But here's the point. That's a process that's in control, brand new piece of machinery, working fantastically well. But that isn't where the noise comes from. The noise doesn't come from the settings. The noise doesn't come from the optimized settings that the computer has worked on. The noise comes from policies and procedures that the company happens to have in order to look after that machinery. So, for instance, maintenance routines. If they choose not to maintain certain things on the robot, maybe the bearings in the articulated arms begin to wear. Maybe they're not lubricating them. Maybe they're not looking after them. Maybe they're not checking them or replacing them. Well, as the variability starts to build up in those bearings, what's the robot going to do? Because what the robot's trying to deal with is this. It's trying to deal with noise. It's not trying to deal with the signal. So the signal, of course, looks like this. And this is where, this is where excellence is. So, you're trying to hit the target then. By the way, you're trying to hit the target with the cheapest or the most practical settings. We'll come back to that in a minute, because maybe the robot can't do that either. So the robot's trying to put a controlled process on a target. Well, now the target keeps moving, because now what you've got is lots of variability coming from the condition of the machine. Maybe we don't put good standard operating procedures about how you strip down and rebuild the machine, so you're doing maintenance really well. But when the technician rebuilds the robot arm, maybe he does it in such a variable way that the robot's completely different every time you strip it and rebuild it. There's all sorts of things. Maybe you buy cheap trays, so the purchasing department, you've got the process optimized. Then the purchasing department go off and buy cheaper plastic trays, and suddenly there's lots of variability in the plastic trays that wasn't there before. What's the robot going to do? Well, it's going to start searching for an answer to this. But there isn't an answer to this. If you've bought more variable plastic trays, there isn't a robot in the world will get you out of that mess. The answer is to go back to the controlled, repeatable, size on size, repeatable trays. Otherwise, you've got a problem. Now, if the robot starts to try and hunt in this environment, what will it do? Well, it'll start moving this thing backwards and forwards, which is exactly what an operator would do, by the way, even without a machine. The trouble with a machine is it's automatic, so it's going to do it automatically. At least an operator is doing other work, and they're not going to do quite so much of this. But if they take that graph, if the machine learning starts hunting for excellence in a very noisy situation, it's just going to make the process get worse and worse and worse. Now, where's most of the problems in most companies that I visit? Those problems are there. They don't get control of the process. They don't have proper policies and procedures. They don't have good maintenance. They don't have good purchasing routines. They don't look at the variability. They don't control variability. Well, if you don't control variability, and that's what control's about, this is pretty much impossible. Now, this was a brand new line, so there isn't a lot of variability in this line at this point. But it's going to come, and then AI is going to be part of the problem. It's not going to be part of the solution if you're not careful. But there's one other thing I want to just counsel you about using AI, and that's the fact that inherently computers are stupid. They are stupid. They don't understand the wider context of how they are working. So for instance, look, I said you want the computer, you want the machine learning to hit the target with the cheapest settings. Now the question I would ask is, does the machine know this? So what the machine is doing, what the software is doing, is trying to create a model. So imagine we have a model, look, that looks like this. So here's the target, y, and we have three variables, x1, x2, x3. They are all numbers between 1 and 10. So now what we do is we ask the machine, as you're learning what these things do, please make sure that you hit 12. 12 is the target. Okay, so give me 3 numbers that hit 12. Well, it could choose 4, 4 and 4. Of course, it equals 12. No problem. Well done. It could have given you, let's have a look. Let's have another one. 6, 3 and 3. Also hits 12. Both to the computer are equally okay, aren't they? But here's the point. In real life, they're not equally okay. Because, how about if I told you this? This is gold, this is silver, and this is dust. Now, if you were trying to optimize this machine and hit 12, which settings would you want it to pick? Well, you'd want it to pick 1, 1, and 10. And that would be an optimized process. Now, the question is, does the machine learning know this? And I don't know whether it does. I didn't get a chance to ask the question, but I don't know whether it does. And so my only kind of advice is, if you're going to give this over to the machine, there's a number of things you've got to be careful of. What about control? Machine learning can't do that. It's just trying to hit the target. And does it know how expensive each dial is? You know, if it says, oh, well, I can optimize this process if I just turn the air pressure up. Well, if you just turn the air pressure up, you're going to cost the company an absolute fortune. Is that okay? Computer don't know that. Computer is stupid, doesn't understand the context. So you've got to be really careful. Now, this is just basic. Here's what's going on in a process. Here's just basic how to optimize a process. There are other issues which I'm not going to talk about, but the other one is that if you allow the computer to randomly interrogate a machine, it will create confounded data. Now this is a real technical problem. Confounded data will tell you lies. That's why we do designed experiments. We do designed experiments to avoid confounded data. Designed experiments are very specific. They have a specific design space. You've chosen where you're going to test. They have a limited number of trials in order to do this. Now, confounded data is going to be part of this. Can it really find the answer? Well, I didn't get the chance to ask the question last week, but I think the gentleman's name was Mark Lecoutre, who did the presentation on AI. I'm going to make sure that he gets to see this video. So Mark, if you're seeing the video, I'd love to give your AI some wisdom, because that's what this is. This is wisdom. Wisdom is knowing not to turn the gold up to high. Knowledge is the equation. Knowledge is the equation. Maybe this thing can get knowledge. Can it get wisdom? And then the other thing I would say is, can it get true knowledge when it's generating confounded data? So AI and Six Sigma, do they fit together? Well, maybe they will in the future when we develop the process even better.